Today's video will talk about how to add output responses in Design Explorer. Now you must be familiar with the options of adding mass as a response, slash volume or displacement or element stresses or strain. But in today's session, we'll talk about how to add the forces from a 1D element or elements, or how to use the option of measure. So but when I say measure, you can find the displacement between two nodes or the distance between two nodes. There are various set of features that we'll cover in today's session, right? So you must be familiar with Design Explorer. So we have enabled the study. We have added 4 design variables, and now we'll add a few responses which will be different from the very typical the mass, displacement and stresses. So let's look at adding 1D force as an output response, right? To do so, the first prerequisite is to have the global output request enabled with the SPC force. So in this case, we have enabled the SPC force, and that's how you'll be able to leverage. Otherwise, you will be prompted for an error if you have not defined it beforehand, right? So let's go ahead and add a 1D element force. So we'll click on force. Now in this case, we'll select load, right? And what we'll do is we'll select one of the SPCs and we'll select the maximum absolute value. We have various options from the max mean, so we'll stick to the basic, which is maximum absolute value, and we'll just click on apply and OK. By doing so, the force 1 value has been created in Design Explorer, right? Let's go ahead and add measure. So now when we click on measure, you get various options. You want to measure the distance between nodes, you want to distance the position between various nodes, the relative displacement between nodes, relative angle between the two set of nodes, or the angle between them, right? In this case, you will have 3 nodes. So let's stick to the basic. We'll only demonstrate one of these, but the process is very similar how you do that in Hyperview. Using the measure option there. So in this case, let's understand the how to add distance between the two nodes. Since it's just a demo example, so we are not very particular about what are we selecting here as such. So when you perform a DOE, you will see that the values do not change in various iterations, because that's how the design is. But in your use case, you may have a relevant scenario where the distance between the two nodes actually changes when performing a DOE optimization. So it can be very handy for you in that case. So in this case, let's select node 1, right? Now just hover on the second point. If you don't, it will select the other one as this one. And let's select the other node and just click on, first you have to click on apply, and then you have to click on this green icon, which is OK. So now that you see that the 2 output responses, one for the 1D force, another for the distance between 2 nodes, has been created. Let's go ahead and perform a DOE. In this case, I'll click on evaluate. I'll select MELS and I'll give 4 runs because it's just a demo video, and just will say run, right? So as we have started the design exploration, it will take some time to finish, right? So in the meanwhile, since it's processing, let me just show you a session which was done beforehand. In this case, if I click on the evaluate, it's the same setup. I will click on the results, and that's how you have the results available for 4 design variables, which is the thickness of the seat tube, top tube, down tube and head tube, and how the force value is varying across 4 number of DOEs, and the displacement, of course, is varying. Now if you see that the measure, it does not vary because this is not a very exact use case demonstrating the benefit of using the distance between the 2 nodes, but this is just a capability demonstration, so you can still leverage this feature and go ahead and make use of it.